Hiroaki Somura is a specialist of hydrology, irrigation, drainage, water quality, watershed management, and rural engineering, and he will present to you his research work in general and in France.
Hi, thank you very much for coming to this room. Yes, actually, I try my best to not to waste your time, actually, yes. So today, I'd like to talk something about this topic. And actually, this topic is not my major, but to suit to you, yes, I'd like to connect my work with somehow health impact. Okay, yes. But actually, I have today 48 slides. It's quite long. And first 15 slides are not related to today's topic, just advertisement of Okayama University or blah, 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 blah. So yes, you can skip. But anyway, I'd like to start. Doesn't move. Yeah, but I pressed the button. Ah, okay. Hi. Thanks so much. And at first, I'd like to talk about my opportunity to come here. I supported by the France Embassy in Japan. The program name is Exploration France, and it is the program to discover new technologies or new knowledge in France to absorb and expand my potential. This is the program basic concept. So in this project, this is my topic, our topic actually, innovative biochemical approaches for smart water quality monitoring. We say in short, booming. And those are our partners, the USMB and University of Poitiers, and also Lab. Yes, so we do together to develop this type of things. And the contents is like, this is not my major again, so truly I may not understand, but to understand the relationship between virus detection and fraction by membrane means. And one of our goal is to develop a passive sampler for collecting the target virus efficiently. This is our main goal, yes. And from now, a little bit, I'd like to talk about Okayama. The Okayama is located here. Okay, so here is Kyoto, here is Hiroshima atomic bomb. You know about Hiroshima, right? Kyoto, you know, right? No, don't know Okayama. You know, great, yes. It's Okayama, and we have a Koraken. It's a beautiful Japanese garden with Okayama Castle. So, and also we have medical school. So if you have opportunities to come to Okayama, we always welcome you too. And we have 10 faculties, again, faculty of letters, and medical school as well. And also I belong to faculty of engineering. In graduate school, we have 7, used to be 8, but last year 2 graduate school was integrated into one for more comprehensive study. And we have 1 hospital as well. And Okayama University is not so big university, so we have only 13,000 students and around 2,000 faculty members. But now, yes, I think that compared to other Japanese universities, we try hard to link with European universities, especially France. So like we have several projects under the European grant scheme. So like a high, this is high energy physics or solid state physics or planetary material something. And also selfie is we selected this year as a security, internet security something. And also plant studies or marine biology or medical something. Also, we have a connection with European countries. So nowadays, the population of European students are increasing in our university. And one of the schemes that we think is very important is Horizon. So this is an international, interdisciplinary, intersectoral, academic or non-academic. Those groups put together to create a new subject for research and education. And also the Erasmus. So I have been to France 3 times. The Professor Dr. Clément mentioned, but because of the Erasmus scheme, I could have the opportunities to visit here for 1 week to discuss or get something information. It would be nice. And also, this scheme has mobility scheme. So students come to Okayama for 1 week to several months to study something or research something under this scheme. So yes, we have that kind of collaboration with European countries. And yes, so international research internship also we accept. So many French European students come to Okayama University in the master course level. So in this year, already 40 to 50 students come to Okayama University for internship program, actually. And the number of students from France are increasing year by year. So it will be very nice if you come to Okayama, not our department, but School of Medicine or pharmacy, yes. And this is a summary. Now, I mentioned that we have a strong connection with European countries, especially France. So I come here under this support. And also Iponoro, that the Clément belongs to, used to be, and he came to Okayama University for 3 months to do the research. And other the Professor Duclaux also tried to come to Okayama University by using the JSPS short-term visiting program. And Erasmus mobilities, so 16 mobilities from USMB to Okayama. It's including staff and faculties, but students' number is also increasing. That the this framework used come and go to France and Okayama. So it's quite important program for us. But anyway, the next is my CV, but these contents have already explained from Clément, so I'd like to skip. And I'd like to introduce what I do, my research currently in Japan. So I am a hydrologist, and my background is agricultural engineering. So it is far from your study, actually, and also far from the various something topics, but I conduct the ecological aspect to understand how the in the water, do you know watershed? Yes, how the watershed activities like agriculture activities or human activities affect the environment, and then that kind of environment affect to the downstream ocean ecosystems. So those kind of topics I conduct in Japan. So in this case, we pay attention to especially iron, because iron is very important for photosynthesis analysis or phytoplankton in ocean side. But if we develop dam reservoirs and upstream, and also if we conduct agriculture activities with pay attention to the environment, then the iron dynamics from upstream to downstream may reduce. And then that reduction may affect to the downstream ocean side ecosystems. So how to make balance between the agriculture or human activities in the watershed to conserve the downstream ecosystems are main topic in current in my laboratory. And also, I will talk more in detail about this topic, but sustainable water environment management for balancing agriculture production and protected forest area in Asian countries, especially Indonesia and Vietnam. So this is Takumi-kun. Now he is in USMB for 6 months to study under the supervision of Professor Duclaux for their research and expand his capacity. But when he is in Japan, he conducted this project. So the protected forest area, yes, so we think protected, but actually environmental degradation is very severe because of coffee plantations. So how we can balance between the production and the environmental conservation. So we conduct. And so today's main topic I'd like to move, it's One Health. Have you heard One Health? How about the SDGs? So it's very similar SDGs and One Health, right? Do you know SDGs? SDGs. You know, yes. So in Japan, SDGs are very popular as a keyword, but not so familiar with One Health. But gradually, One Health is another, how can I say, direction to study in Japan as well, and much more about the health oriented. SDGs is not only the health pay attention to, but One Health is their health. So we pay attention to health, but the health is not only human side, but also the animal side and also environmental side. So because yes, we are in globe, and if our environment became bad, and then we will be affected, of course. And also if the animals, the diversity will reduce, also we may affect. And the affection may affect to the health, actually. So the One Health concept is to think together the health of environment, health of animals, and health of human, putting together and how we can make good environment with good health conditions. So this is the concept. And this concept became much popular between the during the COVID-19. Yes, because COVID-19, I don't know actually the exact reasons, but the animals virus spread out in one city and then spread out entire country and then finally to the globe. It's very in the world. It's very serious problem. So this is very familiar with us as well nowadays. And but One Health, the concept is not new. Actually, 1860s, yes, a part of the concept comes up in a article. And then after that, around 2000, the One Health concept was defined in a journal. Yes, so it is not new, but actually new because compared to the 19 something or 18 something, 100 years, the situation became much changed. Okay, so because of the rapid population growth, then we need to have something land to cultivate for food. We need to have land for building houses. We need to have land for blah 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 blah. those kind of activities reduce the biodiversity and also the environment as well. So once we face that kind of situations, we just again start. It is not good situations. We should consider all the health as one health to protect, of course, our health as well. Yes. And why One Health is important, as I mentioned, like this, the people live closer together, the higher population, especially in city side, many people in the bus, many people in the train, and those people will affect each other. And also, yes, climate change, we say mostly in SDGs, but climate change and land use change or development affect to our health, environment health, animal health, and also more globalization. So, yes, 100 years ago, it might be difficult to come to France, only boat, I guess. But nowadays, only 12 hours or 14 hours flight, then we can reach to France. It's very rapid, so it means that potentially the virus or other something spread out within a day. It is point. And also, the used to be the animals are only the food or the something roads for walking, but now the animals are friends, like families. So it's more closer than before. So those background change became much larger, and we need to consider One Health to protect us, of course. And in One Health, actually, there are several topics like zoonotic diseases, antibiotic resistance, food safety and security, vector-borne disease, environmental health, and chronic disease, etc. But I say One Health, it's only one word, but the point that we pay attention to are quite different among countries. Like Asian countries, the zoonotic disease are much popular, but the European countries, actually environmental health is much popular. So even One Health, one word, but quite different scope, aspect we have. It is very important point. But actually, I don't know the reason why those kind of differences appeared in the world, because One Health is One Health. We may have very much common scope, but it is not true. Why? So I asked to the ChatGPT, what is the reason? Okay, so I typed the question, what are the background differences in culture and society systems for One Health concept in Asia and Europe? Yeah, ChatGPT is very clever, actually, but most of the answers I received from ChatGPT is very similar that I had. Okay, so in ChatGPT, they put 5, 6 items like cultural attitudes, family and community structures, traditional medicine versus modern healthcare, socioeconomic factors, and public health education and awareness, and regulatory frameworks. And what is the difference between Asian countries and European countries? One is, in Asian countries compared to Europe, the animal and human interactions are very close. Of course, you may think the countryside, European countries also, they have cows, they have donkeys, and the people stay together, so it may be close. But yes, only countryside. But in Asian countries, much more closer. Actually, because the city area is small, countryside is small, so we actually packed in the small area. So considering the European countries, yes, we can say the human-animal interaction is very close. And also, yes, those are, of course, but the socio-economical factors, yes, European countries, I think there are many countries in Europe, but the economical level or development level is very similar. Of course, income level or something a little bit different, but magnitude, I mean, diversity is not so big, very small. But Asian countries, okay, Japan used to be very strong country, and now not so strong, but still economical level is the third largest level in the world. But considering the China is the second, but anyway, considering the Southeast Asian countries like Vietnam, Cambodia, Laos, Myanmar, Indonesia, Malaysia, blah, blah, blah. Quite different. Have you been to Asian countries? No. Thailand, so you know Thailand. But Thailand in where is your Thailand? Yeah, Bangkok actually is a capital and also very big city, and we can say it's like a Tokyo actually, but the rural area in Konkan or other areas, it's different, far different from the Bangkok, right? Yes. So among in one country, huge diversity in economical level, but in Asian countries, among countries also big. It is the problem, and also regulatory frameworks. I will mention something later, but in Asian countries, very rapid development, but very slow development of regulations. So it is very challenging once we found something new disease or new factors, and to prevent that kind of thing, disease, but it takes time to make rules. Yes, but European countries, yes, you have very long history in Europe, so it means you have already established rules, regulate the something. So those are quite big differences. That's the reason in One Health concept, we have now in Asian countries, zoonotic disease, but European countries have pay attention to environmental issues under the One Health concept. It's a big difference. And yes, so environmental degradation and risk for human health. Okay, yes, here is a medical school. I'm an environmental engineering part. So how to connect to the environment and health for you too, it was very difficult to think. So I brought One Health to explain. And yes, again, ecosystems play an extremely important role in supporting and nurturing life, including human life, yes. And also the altering these ecosystems can contribute to the outbreak and spread of infectious disease. Yes, it is connection with environment degradation and health. Yes, habitat loss, modification of the natural environment, and biodiversity decline are contributing factors to emerging infectious disease. Actually, yes, like if there is something changing environment, like the mosquitoes, malaria mosquitoes, okay, it may increase the breeding site, and it may affect to the human bodies. And also among the animals, they have some viruses, and interspecies transfer also may happen. But actually, how to affect to human bodies are not well understood yet. So this is one of the important research topic from our side and also from medical school side, I think. And why Asian is important for the environment? As I said before, rapid increment of the populations, so rapid urbanization. Yes. So from village to the urban, and also slow regulation development is one of the issues, and also high pressure of deforestation. Because in Asian countries, we have many forest area, but when we spread out the residential area or agricultural field, we need to cut the trees to make land. Yes. So high pressure of deforestation like this, and also the traditional agriculture management way would be one of the reasons to degrade the environment. So like Swedish agriculture. So we put the fire on the ground to make ash, and then ash made good for soil environment, for quality. So we do this type of things, but if we burn the field in the large scale, then the CO2, carbon dioxide, may emit to the air, and it may affect to the global warming. And this type of agriculture way is a very traditional, and still we do somewhere in the Asian countries. So the water pollution, waterborne disease, air pollution, respiratory illness, soil contamination, heavy metals poisoning, zoonotic disease, the Nipah virus infection, etc., and food security. Those kind of all aspects we have in Asian countries. This is the reason why we need to think the environment and under the concept of One Health. So, okay, I am not a specialist for virus or something, but of course, in Okayama University, there are some researchers who conduct a virus topic. Yes, not microbiology. Yes, especially. So, like they are coordinator in Professor Maeda and Professor Nakahara, and they try to understand the behavior of antibiotic-resistant bacteria, ARB, and also their genes need to be better understood in soil, and also increased ARB in the manure, manure, kind of organic fertilizer that produced from the animal feces. We say manure, yes, may lead to the outbreak of the human disease. Okay, so this is cows, pigs, and birds create feces, and then those input to the soil, and bacteria, anti-ARB, antibiotic-resistant bacteria, will recycle. But then how those ARBs or other bacteria affect to the human bodies, we are not sure yet in the field scale. And also, this is one of my field of research, the watershed scale. Okay, they put the field, and somehow when we have rainfall or something, irrigation water, a part of the ARB will reach to the riverside and then convey discharge from upstream to downstream, but we don't know what kind of behaviors we will observe in the watershed scale about the ARD dynamics or something. And also, it's important, okay, the way of making manure is different in Japan and in Asian countries, Southeast Asian countries especially. Like, okay, Japan, we use aerobic composting procedures. So the high heat will kill the viruses, not perfectly, but then create the manure. But the Asian countries like Vietnam and Indonesia, and blah, 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 they use anaerobic composting method. So low temperature. it may not kill the viruses actually. And also, again, the cows, birds, pigs, during the growing period, they eat a lot of medicine to prevent disease. So during the composting period, it may remain, and some of the bacteria have resistance for the other medicines. It means, okay, and then those ARB contained manures put in the field and used, and of course, in my understanding, those bacteria may not affect the crop itself, but it may spread out the air by wind. So 2 types of methodology to make manure and spread out the agricultural field, the paddy field as well. And then those materials, a part of those materials enter the river and move from upstream to downstream. We don't know actually at all. That's the reason environment and health should connect strongly, tight, and do some research. It is the important thing. Yes, and antibiotic bacteria and in soil, this keyword is much popular nowadays. So I use the Google search and type the keyword and check how many publications already published in the world. In this case, Asia and France only, but many countries publish those keywords topic articles. This is a number of the articles. Yes, 1991 to 1993, this is 3-year interval, but very small, only 2,000 among Japan, China, India, France, only 2,000 around. But then suddenly increased like 10 years ago and rapidly increased. Around here, they're very stable, but this topic is not only for Asian countries, but also France as well. There are many publications. It means we have already knew that the topic is very important. But actually, again, the European country situation and Asian country situations, even Asian countries, Southeast Asia and Japan, China, Korea, quite different. So we should understand because people are pay attention to those influences nowadays. And then I change the story, and from now I'd like to talk something about the environment in Japan and also an example in Southeast Asian countries. Okay, because you may not know about the Japan so much about the health issues and health treatment. Okay, after World War II, we had a very rapid growth in economy, and it's not the new, but 1910 before the World War II, and after the World War II, we have a Itai disease by cadmium. And also 1953 to 1960s, we have a Minamata disease by the mercury compound. And also the Yokkaichi asthma by sulfur oxide and Niigata Minamata disease as well. So this around here is a rapid economic growth in Japan, and we had 4 major pollution-related diseases. It was very serious problem in Japan. So during 1971, the Japanese government established the agency to deal with the environment. Yes. And then around 2000, this agency changed to the Ministry of Environment because late 1960s, yes, another problem happened. We say eutrophication in lakes and reservoirs because after World War II, rapid growth we faced, and we found 4 major pollution diseases But those are easily regulated, well, not easy, but regulated by the rules and reduce the case. But then after that, we need to have more food. And the agricultural ways are being more modernized. Then modernization, it means we apply much more about chemical fertilizers. Used to be we use organic fertilizers, but organic fertilizers affect the crops very slowly. But chemical fertilizers, easy to solve in the water and easy to absorb to the plant. So we apply a lot of fertilizers to the field and eutrophication occur. And then, so the problem was huge. So municipal education started, and also the now being better, but still there was problem for livestock. So 2004 act on the proper management and promotion of use of livestock manure. I will talk something about it later, but yes. So after the 2004, we cannot put manure on the ground, on the field, to prevent the pollution in groundwater or surface water. But then after that, it's quite difficult because we regulate to input the fertilizer amounts and also try to control the discharge nutrient from the field side to the river side. It is good and it was good, but then oligotrophication occur in the coastal zone. So because terrestrial area watershed has a big role to convey the nutrient from upstream to downstream ocean, and the nutrient will be used the ecosystems in the ocean side and then produce fishes or crabs or other things. But too much regulation in the watershed, too low concentration of water come from upstream to ocean side, so reproduction will reduce. So now, not all the area, but oligotrophication is one of the main issue, like Seto Inland Sea, Okayama City. So it is like 1990s. This is my field of research in PhD dissertation. Okay, the big feces put around the field, cows, yes, daily, and groundwater pollution was happened because they put around here is the main livestock farming areas and huge amount of because the area is the second largest livestock area in Japan. It used to be. Number one is Hokkaido, and the number two is this area, and no regulations for dealing with manures. So huge amount of manure, feces put around the ground. And then this is alluvial fan, so gravel layers under the ground, so very high porous. And also this area is high amount of rainfall, around 1,800 millimeter per year. So huge amount of rainfall, capture the nutrient and then infiltrate to the groundwater. And then comes up as a spring water to downstream. Yes. So the downstream concentration of nitrogen become higher year by year, and in the maximum, the concentration was 12 ppm milligram per liter. So the drinking water standard by US EPA is a 10 million per liter. So it exceeded for the drinking water standard. And after that, fortunately or unfortunately, we had a big flood event this year, so 1999. So those feces on the ground was flushed out, then became lower concentration. So this is not the result that we made. Instead, because of the disaster, the concentration was lower, but and later on, again, 2004, the new rules start. So government pays something subsidized to build the facilities for dealing with feces in the town. So anymore, we don't have that kind of trouble, but used to be, we had this type of groundwater pollution. And also the agriculture, in your mind, I think agriculture means like a wheat field or corns. Yes, but in our case, in Japanese, as actually, we say agriculture, it may be imaged as paddy field. Yes. So because half of the agricultural field is paddy field in Japan nowadays. And in the paddy field, the difference between the upland field, corns or wheat, and paddy field is like we use much more water for paddy field for as irrigation water. And the input and output of irrigation water, the water controlled by human. So upland field, just rain or even irrigation sprayed in the area, but no one manage the discharge amount actually. But paddy field, farmers control the gate to inflow and outflow from the field. It means the cause of the pollution will be managed by human. And we had something problem with this. Like for paddy field, first we use paddling procedures. We introduce the water to the field, and then by using tractor machine, we mix with water and soils to make the to pack the soil surface and to reduce the infiltration from the surface ground. And then during that time, we after that transplant the baby rice. Yes, and during that time, the problem is this muddy, huge muddy volume of water discharge from the paddy field to downstream. It is a big problem because paddy field has a something purification mechanism during the irrigation period, I mean the growing period, so there is no problem. But the starting point of the paddy field has huge impact to the environment. It is the one of the concern. And actually, when they plant to baby rice to the field, simultaneously they apply chemical fertilizer. But because of the discharge of the huge amount of water, this is 1 week research to check the internal composite of the fertilizer, in this case, nitrogen. But as you can see, okay, ammonium nitrogen or nitrite nitrogen, nitrate nitrogens, the inorganic nitrogens discharge during the period. And this is only the result of 13 paddy fields, but we have paddy fields along the river from upstream to downstream, and all paddling procedures finished. We need for 1 month around. So first upstream and gradually move the paddling procedures, and then at last 1 month later. It means during 1 month, high polluted water keep discharging from the agriculture field to downstream. And it is a different watershed, but you know Lake Biwa, the largest lake in Japan in Shiga Prefecture. Okay, this is Lake Biwa, and it's very difficult to see, but those are shoreline, and this is river. And as you can see, this is muddy water. So high suspended sediment contain discharge water inflow to the lake. And then it contains a nutrient in the water. So the freshwater red tide happened after mid-1970s. That's the reason eutrophication is one of the main concerns. and Ministry of Education was established. And in May to June is a irrigation period. It means growing season, so relatively higher temperature. And the lake beard's water is used for drinking water as well. So if red tide occurs during the period, it may costly to make good drinking water. So it is a big problem. And next example is Indonesian case. Yes, I like coffee very much. You love coffee very much, right? Because after lunch, we drink coffee. Yes. And in 2022, the FAO statistics, the Indonesia is the third largest producer of coffee beans in the world. And export amount is EA in abbreviation. This amount, very much, 440,000 tons, yes, from the Indonesian statistics. And actually, 4% of Indonesian coffee imported to Japan. And also only 0.2% of export amount from Indonesia to France. You may think, oh, it's small amount from Indonesia, but it is not true because if we think the total amount of coffee beans imported somewhere from to France, it's huge. So the money, the purchase amount is France is number 3 in the world. US dollars, 3.3 billion US dollars. It's huge in 2023. And Japan, 7th. So only 1.6 billion US dollars. But still, we, France, Japan, import huge amount of coffee beans and have fun in the morning, after lunch, and before sleep. I don't know, but anyway. So it means the coffee production in Asian countries or coffee belt countries in the world is not the, how can I say, affect too much to your life. It is not true because if they stop producing coffee, we may lose our fun time, actually. And in Asian countries, yes, illegal farming was spread out previously, like 20th century, 2000 around. And local farmers, yes, want to get income because they are very literally poor. So they aggressively develop the forest area, and the environment became worse. So the government tried to make regulations or control the farmers. So they established new rules, social forestry regulations. It is for support local economic growth and also to provide equity for social welfare and also maintain and protect forest ecosystem functions. Because if the farmers group wants to make something in the protected forest area, they need to make something plan for their production and for conserving the environment to the government. And then they receive permission every year. Now, it's coffee plantation actually 5 to 10 years. So even if they apply every year, but still too late because already developed. But anyway, those kind of frameworks they made. Then what happened? This is one of the watershed in Sumatra Island. The Indonesia is, Jakarta is in Java, but this is Sumatra Island. And used to be, nowadays as well, protected forest area. So the environment should be protected. But more than 90% of the area converted to coffee plantation. It is not good, yes. And actually, one of the very important traditional management strategies they had, actually, naturally, we say agroforestry. Agroforestry is a kind of management strategies to conserve forest ecosystems and also as well as producing crops. So we say agroforestry. Yes, this is ultimate goal. And so this is a photos and illustration of the agroforestry. So the top canopy is an original forest, but the down layers, they have multiple crops. So the canopy, forest canopy can prevent strong rainfall intrusion to the field. So that can be, the soil surface can be protected. And also the multi-layers production means even some crops fail to produce something, but farmers can receive something, crops from other trees in the area. So it's a kind of insurance for them. So under the agroforestry, we can conserve the forestry ecosystems, biodiversity, and also we can also protect the farmers' income as well. So it is the ultimate goal. And if we can make those systems very well, the human activity and forest conservation will be balanced. It will be nice. But the reality is very difficult. Okay, those are the one of the area in the watershed. As you can see, on the ground, nothing. Just clearly cut, and even vegetations, nothing. And then baby trees are planted. So, and then they apply a small amount of fertilizers. So at the end, erosion. So because in Indonesia or Southeast Asian countries, 90%, as you know, 90% of rainfall fall during the rainy season. And here in the mountainous side, the average rainfall amount will be 2,500 millimeter to 3,000 millimeter like. And most of the rain come during the one period, then hit to the ground, and then discharge to the river. So this very muddy. Do you remember the muddy water from the paddy field? Almost the same, or actually much higher concentration of the SS from the natural river than paddy field. So it's quite huge. And also, okay, again, I mentioned in the area, they need to submit some special application, plan for the government to start their cultivation. But as you can see, along the river, very close to the riverside, they plant the coffee trees. It's very difficult to protect the environment, but once they receive the permission, because of the area is a very mountainous side, it's difficult to access for the governmental officers. So yes, along the road, very nice. But once we enter inside of the watershed, the environment is very much worse, degraded. So when we collect the samples and analyze the chemicals, water quality, and we found that there are two rivers in the area, and quite different features. One river shows higher nutrient, not so high, but higher nutrient than this watershed. But this watershed has higher SS discharge and heavy metals. So, both watershed has maintained by different groups. So different phenomena happened, but still it is not good for the environment. And one thing is not nutrient, but the heavy metals. This is the EPA water drinking standard, and those two watersheds exceed the minimum level. It means, yes, the water is used for drinking, water is used for bathing, water used for cooking, actually. So it may affect to the health in the villagers, of the villagers. So it is big issues. And eutrophication or nitrogen agriculture, those topics are much, much popular in the world. And as I mentioned before, I used to Google Scholar search and all PO language articles up to 2000. Yes, there are several, and France as well produced many articles, but not so many compared to the antibiotic something. But anyway, because antibiotic something, the topics will be much faster to get the result. But environmental issues, it takes time. So well, at least two or 3 years we need to publish. So it is a reason the number is limited. And yes, especially China has produced many papers after 2008, and France also continuously produced the eutrophication related topics in the journal. But yes, again, Asian countries are much higher publication speed numbers than France. And you may think, yes, I mentioned Japan and Indonesian case, but actually the degradation of water environment affect to the health is spread entirely Asian countries. So this is the one of the data set obtained from WHO, and this is Southeast Asia, and yes, Africa. The mortality rate in Africa is much higher than Asian countries, but Southeast Asian countries also 30% of the mortality rate related to the unsafe water. So it's huge problem, and yes, European countries only 4%. So you may have a little bit problem, but again, South Africa and Southeast Asian countries has huge concern for unsafe water and also health problems. And mostly India has higher percentage. And this is one of the summary. So nutrients, yes, I talked about nitrogen especially, but nutrients, nitrogen, phosphorus has influence against human health. One is a large amount of residual agricultural nutrients is discharged into ground and surface waters, resulting in the rapid increase of nitrogen content, especially nitrate, in the environment. And also nitrates, especially, cause many environmental degradations, such as eutrophication. Yes, nitrogen is much higher mobility than phosphate. So that's the reason nitrogen is one more major concern for eutrophication in the rivers, lakes, and groundwater. And also nitrate, if you put a lot of nitrate, soil acidification occur, so it may affect to the crop growth. If we put inadequate species we plant. And also greenhouse gas effect. So nitrogen in the soil may convert to the N2O. Normally, if the environment is good, nitrate goes to N2 and to the air. The N2 gas is not harmful, so it's okay. But if intermediate steps, if the N2O was produced, then the global warming gas. So it may affect to the environment as well. And also the nitrate also cause negative impact to human bodies, blue baby syndrome, and malaria. Malaria is not directly affected by the nitrate, but again, if we develop the area, and then if we discharge on the high concentration of nitrate, then the developing area of downstream vegetation may change, or the travel time of the nitrate in the water is changed. Then sometimes the good environment for malaria mosquitoes established occasionally, then it may affect. And also, yes, harmful algal blooms like this may affect to the environment. Also, if we drink, we don't drink this type of thing, but even a treat, but a part of the toxin may remain inside, it may affect the human bodies. So, okay, what kind of solutions? This part is very difficult for me to mention, but this is one of my answer. So the numerical modeling is one of the useful tool because in this case, hydrological model. The hydrological model reproduce the water dynamics of the watershed scale or field scale. And the materials in the field conveyed by normally water or wind. The water is much major than wind. So if we reproduce the water dynamics in the watershed scale or field scale with the particles that we pay attention to, like in this case, nitrogen, then we may be able to trace where this nitrogen comes from and where is the source of the nitrogen. Like those kind of visualization is very important. And also one of the important point that we use model is scenarios. Because just only the detecting the source or detecting the pathway of the pollutant load, it is important, but it not be enough. But how to reduce the impact of the nutrient load in the environment, the scenarios are very important, but the model in a virtual. So we can put any circumstances, any level of circumstances to the model and see what happened, what changed, how much changed our treatment to the environment. So the modeling is one of the robust tools to understand, visualize and understand and evaluate and making scenarios and future conditions, estimating future conditions. So like this. So water is moved. So and then the materials also move. So we can see where is the source, where is the pathway, main pathway. Like I'm sorry. And then this is one of the examples, like management plan A, management plan B, and also the change of land use, how much reduction we can expect. These kind of potential improvement of the target element can be obtained by the scenarios, and also this type of visualization is very important to discuss among people. Yes, so the modeling is very useful. And also, what kind of point that we Asian countries from Asian country to export to Europe, this is very not so interesting maybe, but community-based initiative and also low-cost technologies. The community-based initiative, as an example, is a Lake Biwa. Yes, as you saw this slide, muddy water during the polling procedures inflow to the Lake Biwa and then damaged to the environment. So the local community group members take an initiative to conserve the Lake Biwa environment, like no muddy water campaign. Like government doesn't do anything, but the local community members started this type of activities to conserve their environment. And also, this is a fish habitat conservation campaigns. So when we developed the paddy field systems, a part of the fishes was prevented the migration from Lake Biwa to the paddy field, but some of the species need paddy field for reproduction. So they make something fishway to support migration from Lake Weir to paddy field to Lake Weir, like to reverse the national condition. And this is a community-based initiative examples. Actually, those kind of activities are spread out entirely Asian countries. And yes, it is very difficult to list up everything because huge amount of activities have already reported in the world, in the literature. But yes, Asia, strong cultural traditions of collectivism and mutual aid. Yes, we have. And cooperation and community engagement are very strong. So, okay, communities often possess variable traditional knowledge about their ecosystems and sustainable practices. So, like the China wetland restoration, native vegetation conservation, or Thailand, Vietnam or Thailand, somewhere, yeah, Thailand, yes, coastal water quality protected shorelines, sustainable fishing practices like in Philippines or Indonesia or Vietnam, rice, river cleanup, reforestation, and sustainable waste management. Like those kind of activities are started by the local community members, not government direction instructions. So this is one of the important aspects. And also next is low cost technologies. Yes, the reason why, especially Japanese university, pay attention to the low cost technologies. As I say before, among Asian countries, the huge diverse of economic situation we have. So even we produce or develop very high-tech, expensive technologies, but no one can use in Asian countries because they don't have enough budget, right? So all the time we pay attention to low-cost technologies. And as I said, this is biochar. In agriculture field, we apply chemical fertilizer as nitrate. And then sometimes it goes to the air as a nitrous oxide, so N2O, and then contribute to the global warming. But we know that the biochar is a char produced normally, in this case, from the agri waste. And also we add some functions. Truly, when we make biochar, we put some iron before the making biochar. And then, if so, the biochar has more electron than normal biochar. So the synergy with electron and defiltration, nitrificating microorganism, the microorganism can work very well to reduce or proceed from the nitrate to N2 gas. We know. So it may be good for the global warming prevention. And also, once we add different functions to the biochar, it can be materials to adsorb nitrate on the surface of the biochar. So it means if the biochar can capture the nitrate in the soil and prevent to discharge to the riverside and groundwater, then it means we can reduce the eutrophication of the rivers and groundwater. And especially Okayama University, we pay attention to the agri-organic waste because it's a free of charge mostly, and we not used to be disposed. But if we can use that disposed agri waste for cleaning the environment and make more functional materials, it will be nice for them as well to sell and new income they receive. So in our case as well, this is a local agri waste and forest waste. We make a nanoparticle sized biochar. But we say nanoparticles may affect to the environment negatively, but it is true, but in this case not true, because each particle is nano size, but we create the chained materials. So nanoparticles, but actually not the look like nanoparticles. It's like chains, huge something materials. But when we use the microscopy, we can see the nano particle size. So it means surface area is maximized, very huge. So the function will be much higher. This is low cost. And then we input to the agricultural field, again, increase N absorption by crops because retention time of nitrate will be increased because of the biochar. And also, the excess nitrate may go to the air, but the biochar accelerate from nitrate to the N2 gas, not N2O. So it would be nice for reducing GHG gas emissions. And those kind of low-cost technologies are not conducted in Okayama University, but also other universities have different type of techniques. But the keyword is low cost, like biochar, as I say biochar, but in our case, agri waste. But some universities take sewage slag to make biochar and incorporate to soil and water treatment. And also artificial wetland, yes, this is a water treatment, a nutrient removal, but different type of artificial wetland they designed. And also this is electrocoagulation and SMFC. SMFC is the soil microbial fuel cell. So normally, especially SMFC is for generating electricity from the soil. But we use the SMFC for water treatment because in our experiment, we figured out SMFC, when we incorporate SMFC in the soil, then redox potential will be was increased. It means if redox potential decreased, methane will be produced. But because of the SMFC, redox potential is much higher, so it means we can reduce methane emission like. And also the biochar, because of biochar, pH also changed, the condition changed. So the phosphate released from the surface of the soil to the water also reduced because of the pH change. Yes, so this is the conclusions. So points of the caution in One Health are different between the European countries and Asian countries because of the maturity of social development. And also, yes. And also the environmental degradation by agricultural activities will be much severe in Asian countries because of the environmental awareness or income point of view. And also the effective remediation strategies. Yes, this is today's topic, and I mentioned strongly about the effective remediation strategies, but actually it's depending on the accurate identifying the source, root cause of the environmental degradations. It's depending on each circumstances, so it may be difficult, but we should accurately understand the pollution source or overuse of the natural resources. And also, the hydrological modeling is a key tool in understanding and predicting water-related environmental issues, because it provides a clear visualization that can help stakeholders grasp the scope of problems and explore the solutions. And the last part is what kind of things we can deliver from Asian countries to Europe. Maybe the potential for adopting the community-driven, cost-effective solutions from developing countries for use in Western context can be beneficial, we believe, especially addressing the local scale environmental and agricultural issues in Europe. はい。じゃあ、Thank you very much. This is my talk. はい。はい。